I work as a test automation engineer at Neat. Neat makes video conferencing solutions. So I am definitely non-binary. I have worked in software as a software developer since 2001, and have had a gradually increasing interest in automated test automation, probably long came over the bar of an unhealthy interest. My last two employments, my current one and the previous one, have been 100% focused on autotesting embedded software solutions. Now I am a senior test engineer at Neat. Just as a note, my partner is Swedish, and she calls me test Nisse. Those who know a little bit about Swedish, Nisse is not at all as pejorative in Swedish as it is in Norwegian. For those who don't know the joke, Nisse probably can be translated as idiot in Norwegian, whereas in Swedish it's maybe well translated as dude. So that's a bit about me. Okay, so the first thing is, let me ask the question, why do you auto-test? And I won't ask for so much audience participation here. So if there's something that's really unclear, please raise your hand, but otherwise we'll try to save the questions to the end. And I think it's good to have a enunciated, a good understanding of why you're investing in auto testing, because it has a lot of cost. So there's a couple things here that I could think of. So we test every night on alpha and all the other branches, or channels. We use channels at Neat basically to be able to identify what is a good release candidate to take further from alpha to dev to canary to, yeah. And the other thing is a gatekeeper to keep the white walkers out of your code base. So running every night on alpha and other branches, and keeping nasty bugs out. And I'll give you some examples of some nasty bugs that we've caught at Neat with auto testing. So at Neat we do both of these things. But fundamentally, both of these things basically depend on something I'm going to call situational awareness. Because you're not going to keep regressions out of your code base if you don't see them coming. So you need this situational awareness to actually, and the other thing is you can't confidently promote a build to the next level in the release channel if you don't know what the issues in it are. By the way, has anybody ever promoted a build or gone further with something that had no issues in it? Probably not. Usually not. Maybe some greenfield thing. So what about this situational awareness concept? I've been to a few software conferences. Kate Gregory mentioned solid. So the L in solid is Liskov. Does anybody remember a short sort of statement of Liskov? I won't ask for an answer. I'll just put it up there. Of course, yeah, so easy, right? If you look at it and read it slow, you say, yeah, that makes sense. But here I'm not gonna make you think that hard, because situational awareness we can illustrate by a much pleasant and more simpler means, namely memes. There's an example of situational awareness, a negative example, right? So we can continue with the memes-based explanation of this situational awareness concept. This is like what I like to say is developers looking at a dashboard for nightly tests. The coast looks a little bit clear. There's something a little bit dodgy here. I'm not sure what it is, but looks good. Looks all right. Let's see. Oops, that went a little fast. See that dodgy thing? Oh, that was just a warning light. That was nothing. So what's the difference here between the static last night's, hey, this is last night's test runs on a dashboard, and this one here? What's the difference? Well, let me pull up a definition of situational awareness. Situational awareness is the perception of environmental elements, so that environment that is your code, basically, and events within maybe the tests on that code with respect to time or space, right? But time. So that's the difference between that and that. It's time, right? So the perception of these elements and events with respect to time or space and the comprehension of their meaning and the projection of their future status, right? And so that's the difference. I think this is my claim. People, we have question and answers and responses, so maybe I'm doing this dead wrong, but I think a lot of developers are looking at tests on a dashboard and looking at a fairly static picture that's not taking into account time. So you're looking at space. You're looking at all the places in your system where you have perhaps failing tests. Different places here, 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 here. Space. But I'm going to try and convince you today that you should pay attention to time. Yeah, so there. More memes or whatever. You know, you got the reference, right? Yeah. Okay, so hey, this is the Autotest department's dashboard. It's actually just filtered on one build, but I will ask for audience participation. Does anybody have this much time on your test dashboard? Good. You've probably just exempted yourself from the talk. you can come up and take over. Good. Yeah. So we have a lot of things. Yeah, I'll go over what a little bit. I'll zoom in on a few of these, but actually I'll zoom in on several of these in the talk, so I don't have to go through it all now. We're at a software concert. Software concert, that would be cool. No, software conference. So I have to, if I'm bringing in a completely new concept, situational awareness, not a tough concept, not Liskov, right? But if I am bringing it, I need to situate it relative to known buzzwords. So observability, right? Everybody's heard about observability. And I've come up with the Maslow's pyramid of testing needs, right? The basic level. And, it is sort of like, I don't know what the bottom of the normal Maslow pyramid is, but, it's like food, water, that kind of stuff. So you need tests, right? If you don't think you need tests, I think you chose the wrong session. Okay, just a hint. So that's the bottom level, and it's better than nothing. If you just have tests, not any observability on the tests, but just tests, that's okay. Observability is the ability to see what happened with those tests. So each level, succeeding level, depends on the preceding, right? And it's not a guarantee that you've climbed up any of these steps on the pyramid. You might have tests and no observability, but you might have tests, and then you might have a good ability to see what happened with the tests. But you might not have climbed up to the level of having good timelines over that observability. So you can observe what has happened over time. And if you have that, well, situational awareness actually is sort of depends on you being able to interpret those timelines, right? So you might have timelines and they might be useless. So if you have timelines that actually are meaningful, that give insights, then you've reached the top of the pyramid. So that's situational awareness. So let me just give you a quick example to illustrate this. So this is a block that you saw on the big dashboard, and I've just filtered out the incredibly badly named job basic tests. And we see some history. We see that on pipeline, we use GitLab CI, very similar to GitHub Actions, although GitLab came first. at a previous employer, I was using Jenkins, so automation service basically. We can see that on pipeline ID, the one ending in 113, yeah, okay, that looked like a little less than the average number of, this side here was executed test suites, and this is duration, so it looked like about the average number ran. Something went horrible on 773, happens sometimes, back to normal on the other ones, and then up here, what was this hop? If we look at just this one, for example, which is time, on the right, job duration, we might think, oh, something must have gone really, really wrong. Something just got stuck. And this can happen in a test run, right? And might start digging around and trying to figure out which test or tests got stuck, the device got in what weird state. But if you put them together, you see what actually happened, right? Did they take twice as much time? No. Somebody just reran the job. And in GitLab CI, when you rerun a job, it reuses the pipeline ID. So, oh, okay, that wasn't a problem. That was not a big issue. So this is an example of a timeline, or actually a pair of timelines, some correlated timelines, taking you to an insight. Yeah, I don't need to worry about this, right? We saw this and actually wasted a little bit of time. I wasted a little bit of time. Why did we get this giant spike? And then we realized that was the case. So then we just put these two right next to each other on the dashboard. But it's not always easy to maintain situational awareness. And I probably think I'm not alone in experiencing that unreliable test runs lose value very fast with a small number of failures. So on the red plot, you have the number of failures, and on the black line, it's the decrease in value. And this is a bitter truth about autotest jobs. At a certain point, there's just so many failures and so many follow-up failures from failures that your whole test run is a wash. It has basically no value. That happens really, really quickly because you can't figure out what the signal, the important things, important events to noise ratio is. That's why that's a primary reason why your test run loses all value. It's also because a lot of your tests don't even get a chance to really run because the device under test or devices under test were basically knocked out. So there's other reasons. But let's take a look at how sort of this timeline focus can maybe save us from this. So this is real. This is, we have video conferencing devices. That's what Neat makes, by the way. You'll see a little bit of functionality about them. We have, for example, a control unit that's controlling a camera unit, and we have to pair them. And our office has 1 million devices, so the Wi-Fi is a little bit sort of difficult, and we've decided maybe we're not gonna try to fix that because we know other customers can have sort of a difficult Wi-Fi topology. So we've basically decided that we're gonna track failures, and we know that these Wi-Fi pairing tests are flaky, and that's just how it is. And we could either just close our eyes to it and just stop this test run, but then we wouldn't see how the situation is evolving if we're trying to fix the problem, right? So that's what this is. And we do a lot of ad hoc queries in our dashboard, targeted ad hoc queries to follow issues. And this is a definite issue. And so you see red and blue. So the red is sum of failures, and the blue is the count of runs. And you see this is really, really flaky. And flaky, 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 bam. Not flaky. Total failure, right? It would be, I presented this and somebody said, oh, it'd be nice if you had a few more bars that looked just like this one. And maybe it would be, but we caught the bug, right? When we saw this one, you saw flaky, 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 nope. When nope came up, then we investigated, and Yeah, that was a significant regression. Sent it back to the team working with that, and they fixed the bug, right? So we didn't get, since this is a real, not fake slide, we didn't get several of those. But that's kind of a victory. This is on alpha. This is tracking alpha. So anything gets fixed in alpha is just a victory for humanity, basically. One slight caveat: when you're dealing with things that are going to be flaky over time, and unfortunately some things will be. Uh, when you're running tests, uh, yeah, we probably shouldn't involve the dev team all the time when we have noise, right? So that's an interesting thing. You have to weigh, is this really a problem? And this kind of timeline approach is what can lead you to see flaky, but not a problem, known issue, flaky, bang, Houston, we have a problem. Um, yeah. Are there any downsides to rerunning failing tests? I wonder. Well, uh, we use GitLab CI, and with that flaky test run, here's the YAML behind it. And this is, if you don't first succeed, try again, expressed in YAML. I really like that retry property. That's great. But the problem is when we come in, roll in the morning and look at the sort of the GitLab UI, and we look at this job, Wi-Fi tests, looks green. Looks like there was no struggle last night. Is this a problem? Well, I was looking for this quote I had in my head. I hope you know this is going down in your permanent record. I thought it was a movie, then I realized it was a line from a great song from an 80s band named the Violent Femmes. And so basically all failures in the setup we have, which is timeline focused, go down on the permanent record. So no, it's not a problem. It's good we're relying on something a little bit more sophisticated than just the default tools we get from GitLab. I love GitLab, but we need to basically have more observability and maybe things that build situational awareness on top of the default. But here's a question for you. Is it possible to also identify what I'm going to call here qualitative regressions? And you saw this in the dashboard. This one is the sort of the main offenders list. This is the top 10 failing test cases right here. And one of them is testing a really cool, neat functionality that I'm going to present a little bit called subject boundary. And no, we don't see. Here's a timeline over failures over time, and we don't see sort of flaky. Nope, it's not going to look like that. It's going to look like flaky, flakier, maybe at the best. So what we're trying to catch is the absolute failure, and so I do all my doodles in color paint, so sorry, it looks a little childish, but I think you might recognize the first one up there from the first graphic I showed where it's flaky, nope. Versus this one, the qualitative one. And the answer is yes, if it's in your face every day, you are going to catch when you get a qualitative failure. And really suggest that it's a nice way of doing things is start with one query, get an overview of where your issues are, and then from that insight, you can sort of drill in and write more ad hoc queries to follow specifically those data points. There's a lot of tools for doing this. We use the Elasticsearch. I'm a big fan, but this is going to be a fairly tool agnostic talk just about the approaches. So let's do a little bit of a case study. I just want to double check the time. So I am going till 12:40, so great, it's 12. So this is a case study. This is a real case study from experiences we had. And so last night, in this case study. The automatic end-to-end functional regression tests did three meaningful things they were intended to do with respect to situational awareness. The first one, and this one I think is a sort of a undervalued concern. It made us aware of significant system changes. Do you, who have some kind of tests, are you always aware of the kind of big significant changes coming into the system at every point? I see some people nodding, yeah, yeah. The guy with the timeline is nodding, yeah, yeah. But other people are nodding no, right? So this is a little bit of an undervalued thing. We've got a lot of people doing a lot of things at NEAT and Fornebu. But we don't necessarily, everybody doesn't necessarily sort of have godlike overview of all the new stuff that people are doing or changing, right? So this is a really valuable insight to have. The other thing it did was, and this is kind of a basic one, identify where changes in one place broke system functionality, important system functionality, in another place. And that's kind of the basic one, right? That's what we want to do with an auto-testing strategy. And this is another one that's maybe a little bit undervalued, but I think it's really important. It identified where tests were broken because of these changes. And this is like, real problems are never simple. All real problems are complex. All real problems are a knot, a Gordian knot of sub-problems, right? So this was a great one because we got these three things. There was a big change. It broke tests. So sort of our situational awareness sensors got broken. So that's bad. And it also broke system functionality. And these things don't always happen together, but they happen together, and I will try to illustrate that we saw all these. So let's see what the significant change was. Okay, the significant change was on our devices. When we're setting up a device, a new device, when you unbox the device, if you go to NEAT's website, you can see lots of unboxing because, we want to have a really neat experience. Neat, get it? Fun, yeah. And so the out-of-the-box experience, we try to make that really, really good. And, it's kind of, it's your first experience with the product, so we sort of don't want it to be awful, We try to make a good impression. Okay. So Wi-Fi, somebody decided we just default have Wi-Fi off because a lot of our corporate customers, they've got Ethernet. They just stick the RJ45 into the unit, and why should Wi-Fi be default on, right? If you need Wi-Fi, you can activate it. Seemed reasonable enough, and I'm not going to say something bad about the people who made that choice, because as software developers, basically it has been shown by studies that it is absolutely impossible, humanly impossible, to see all of the effects of every change you make. So if the bar is that you should have that sort of godlike view of things, well, yeah, that's, sorry, I can't do that job, right? And you can't do the job. Nobody can do the job. Okay. This turned out a little bit, okay, but you can still see, I think it was better with the dark screen. But here, changes in the making Wi-Fi default off had a sort of really awful consequence. You can't actually see it. I don't think you can see it, but there's a continue button right here. And this is the out-of-the-box experience. So this is what we want to be a really neat experience when maybe a home user, non-corporate user, or a corporate user that just has Wi-Fi is setting up the device. They don't have a Ethernet cable in. They're setting up the device, and in that case, the out-of-the-box sort of sequence of screens wizard takes you to, connect me to Wi-Fi. And it's got somewhere, it's disappeared here, but it's got a continue button. And that continue button is grayed out just as long as you haven't connected to a Wi-Fi. And you're not at a point where system settings are accessible, right? So it's default off in system settings, but this is the out-of-box experience, right? So how am I going to go further? you're not, right? So this is a sort of awful regression, right? Um, okay. So we caught that, right? That's the good news. The other thing, identify when tests are broken because of changes. I'm going to go into our the way we use page object models. That's sort of testing's one sort of own design pattern. We get one page object model. So this is a little snippet from our page object model. And we're running through the page object model, all the classes basically, in a job in GitLab CI, which is called GUI sanity. And where I've got the little arrow there, it breaks because the one that goes through this network path where it's doing out of the box gets stuck, right? So this is the third thing we managed to do. We managed to identify where our tests broke. And that's a fantastic thing for situational awareness because you always or often are in doubt about is this a real test failure or is this a false positive? And we knew this was a real failure because because it got stuck when we tried to navigate further in the out-of-the-box experience. It got stuck here. So this is a special test run that does not test the device. It tests our test framework. It tests our page object model, which is just, I'll talk about the page object model, but page object model in a short sort of way encapsulates in one place all references to GUI elements, all navigation paths through the application, and all operations, or a lot of significant operations that transpire at a specific place in the GUI, right? So here was the place where we got the signal that, yep, we have broken functionality, and we also have broken tests. And for situational awareness, we want to avoid false positives because they make it they cloud the situation, or they make it so other tests don't run, so we don't actually see what the situation is. So this was a victory for humanity, just to sum it up. Everybody did everything right. The developers made reusable components, as we would hope they would do, right? We don't want to have a definition for a Wi-Fi component for system settings and one for out of the box. But they changed the contract a little bit for that component in one setting, which broke the contract in the other setting. And we caught that in the test. So everybody did everything right. We can't complain about the developer. We caught this in alpha, right? So that's just a victory for humanity. It didn't go further. Everybody knows about the timeline of how early you catch a regression and how much it costs when it gets out to the customer. It's somewhere up here. It ends up not just costing you time and frustration, but even your company's reputation, right? So you want to avoid that. So let's talk about some strategies for running as many tests as we possibly can. And this is really important for situational awareness because tests, usage of the real sort of utility of tests is to create situational awareness, but they can't do it if they're not running, right? And it happens a lot that we get knockoff failures where, for example, the device goes into some kind of state that we have trouble recovering from to run the next test. So we want to have some strategies for getting as many tests as possible to actually run. And the reason why you want to do this is, I don't know if other people have discovered this as a fundamental law of the universe, but awful bugs will always sneak in when the tests covering a given functional area are not running. Some people are smiling, so that might be a glimmer of recognition of shared pain. So one thing we've done, so sorry if people are not using YAML-based automation server-ish things like GitLab or GitHub Actions, but I did exactly the same thing with Jenkins. So the same strategy works with Jenkins. We basically just have a possibility here. We're inheriting from sort of a base job. GitLab YAML has some nice inheritance functionality, which makes it so that we can define our jobs and get a lot of things kind of encapsulated away that do really useful things for us, like amongst other things, reporting to Elasticstack. But here, basically, we inherit a base cleanup script from the base, which is the default. And at particular moments in a test run, we can override it. And so that's exactly what I'm doing here, where I'm just setting a different value to the environmental variable. And that actually has been something really, really decisive for keeping the number of test cases actually executed constant. You saw I presented that graph that showed the number of test cases, and this has been an incredibly simple and good way to keep that number high, to think about some kind of recovery strategy. And we have different scripts that fix in different situations. Yeah, so here's the implementation. Shell script. So bash shell script. Everybody loves bash, right? And basically, yeah, if we have a error and if we have a cleanup script defined, then we go ahead and execute that cleanup script. So easy as that. I'll just note in passing, I previously was doing this with Jenkins and thought, oh, I really should be using the Jenkins pipeline syntax instead of having pretty much shell script driven flows in Jenkins. And then I went over to using GitLab CI and also have some open source projects in GitHub, and realized that the sort of the responsible sort of correct way to handle complexity is just to use shell scripting. So I like to say it was visionary laziness. Jenkins is a great product, but nevertheless. Okay, another variant of the same. This is Gherkin. We're using Python behave for executing Gherkin. Absolutely love Python behave. Favorite, but you can do this in any kind of test framework. So we're using some tags for flow control. So one of these is stop after failed scenario. So if this one fails, which is setting up some requirements for a test, then we won't go further, right? But there's a little bit of a joker. On the scenario level, we can add an always. And that always can go ahead and make sure that we get the device back to a state in which it will be ready for running the next test. So that's just another variant of doing some kind of cleanup action to make sure we can go further in the test run and maintain as many running tests as possible and maintain situational awareness as much as possible. Another way to avoid massive disaster if you have a GUI is the page object model. Was it Kent Beck? Maybe. Okay. Somebody, design pattern guy, gave testing its only sort of native design pattern. And this is an example. So basically, the page object model represents your GUI, represents navigation paths through your GUI, represents operations at specific places in the GUI. And so there's a bunch of classes basically representing the GUI. And we've done something. We've got a page object model here. I'll go into the details, but I'll just explain why the page object model is so important for getting as many tests to run every night. And thereby maintaining situational awareness. It's because when you have a GUI change and all references to the GUI are sprinkled everywhere throughout your code, right? You're going to be down for a while because we've already admitted that we don't necessarily know when there's a big change coming, right? And so somebody makes a significant GUI change. We don't know if the failing tests are actual software problems or false positives because the GUI references sprinkled through all of our test code are suddenly wrong, right? So we have a big mess, and what is going to happen at that point? Of course, several complex bugs are just going to sneak into the code base. So having a page object model where all references to the GUI are defined in one place. So it's a dry principle supporting mechanism. Don't repeat yourself. Have all references in just one place. That can save you, help you be agile in the sense of being able to get back on your feet. Oh, there was a GUI change here. Okay, that broke the 50 tests. Yeah, I changed one line of code, did it yesterday, and we're back up and rolling. Right? So not too many bugs could sneak in. How we do page object model at Neat. We start by setting the scene. So you see the given I am on the Zoom welcome screen. And this actually has a sort of double benefit. We realized with these functional end-to-end tests, if we're in the GUI, a lot of times people reading the test, and we want these kinds of tests here to be readable, have no idea in the system where they are at the beginning of the test. And that's an incredibly sort of important first thing to know when you're trying to read and understand a test. So we establish the scene. And it is a string. That might sound dangerous, but we basically transform the string according to a very concise and precise and well unit tested set of rules so that we can get a class reference from it. This is definitely not solid, but again, different rules apply for tests. We want tests to fail loud and fast when there's a problem. So solid in testing takes a slightly different turn. So if this is a little bit brittle, that's fine. Because if it's saying, no, you just wrote something completely wrong, you're going, yeah, we want to know about that fast. We can do something a little bit cool, I think. Have a little chaining operator. And very often we need to do a little bit of a click, click, click through here. And can do that really, really concisely. And I think by a fairly readable way. And I don't know if I have, so this one, for example, this line, we're doing operations. So here we're dealing with display preferences, DPI settings, and we come to a particular place, display preference screen in system settings, and then we do operations on that particular screen, right? So yeah, nothing super groundbreaking, but it works well for us, and it's obviously saving us from disaster and bugs sneaking in when we're not aware. Here's what it looks like, the classes. So you would, this OOB choose setup basically gets transformed to the class name, which gets plucked up dynamically. So that's how we do set the context. We've got different navigation functions. On, so we start with an on, given I am on the welcome screen, and that has an assert, and that's going to fail if the selector for that indicates that you're on that screen is not found. And that's kind of an assert in itself. So often after we've done something and maybe the screen is going to automatically change, I can, say, and I am on, or then I am on this other screen. And also, yeah, we've got operations, so choose setup, so we can set up pairing with different kinds of devices. Yeah. So this is what the sanity test looks like. We've got some nice logging, which basically is just dumping instance information. So of the instance, the page, you've got a type of page an instance of a type of page that's representing the GUI, and you can follow that we're going here, here, and here, and here. So we can debug it, and we can see exactly this is the test run that's just testing the page object model. Kind of testing the device too, because if there's something terribly wrong and we can't navigate, that is a bug. But it's mainly just making sure that we can distinguish from false positives from real failures. All this focus on a page object model can lead us to making the uninitiated, so those who kind of don't necessarily have aren't specialized in testing, think that automated testing is a matter of using the GUI. It's not. Stay away from the GUI, please, unless the point of your test is to test the GUI, right? The GUI, and this models a real conversation I've had. You notice that software architects always have hats and wear Lady Gaga-style beef suits. Yeah. But, I was using super dangerous internal. Yes, I know. And of course I got, no, you can't use that. Why can't you just use the GUI to set this up? Because the GUI is flaky. The GUI is flaky even when it doesn't change. GUI automation is difficult, flaky, slow, unreliable. So my experience is, so this is the justification, by the way. This is always the justification, or one of the main justifications why you can't use super dangerous internal. The developers want to make sure that they can change the contract for super dangerous internal. I understand that, but my experience from, so this isn't empirical experience, but this is a lot of experience, is that even depending on super dangerous internal is significantly less flaky than depending on the GUI, even when the GUI does not change. So yes, I take my responsibilities, I'll depend on that, but you can mitigate this a little bit. The easiest one, and I think we came to kind of got an agreement with the hat and beef suit guy. No, nice people. Everybody I've worked with is nice. Well, we can just put a comment in the code there around super dangerous internal. Talked to the test automation team before you change it. Well, incredibly simple. It works. We don't say you can't change it, just say, give us a heads up, please. The other thing is expose it as test instrumentation. This is your role as a test automation person or test writer, right? You basically can't have enough test instrumentation. So man after midnight or test instrumentation. Okay. But even with the best test instrumentation and all these, good coverage, your test coverage, and we can talk about test coverage in functional end-to-end tests. It's coverage of requirements, not code, by the way. That's the definition. Your test coverage is only as good as your tests are. And that's the same thing with any kind of code coverage, right? So you can have 100% coverage with worthless tests and you have nothing. I was going to demonstrate something here last year, but we hadn't completely open sourced it. So this is something I've made. Hopefully it comes up. So it's a GUI for Python Behave. Python Behave is my absolute favorite test framework. And so you have this gherkin, this given when then, and Python Behave is pretty, in some ways, very simple, nice thing. Every statement maps to a Python function with or without arguments. Python Behave exposes massive amounts of metadata, so it was really easy to make a GUI. So I'll actually demonstrate this a little bit, but this is an open source project. So open sourced of Tumra. There's some Tumra people here, so thank you for supporting this. You can find it under Behave contrib, Python Behave. Let's see if I can actually get back to the tab. I did. Okay, I'll give you a little bit of demo of what it looks like. So how, and this is a demonstration of how, so I'm using, this is a little thing that you can also find under my GitHub projects. It's just another open source project that I just modified to make a little bit of a navigator. And here we're actually going to live demo Behave GUI. And so it has a lot of things here. You can just drop in new test steps. You can also, I think this is a bit of a, addresses a problem with Gherkin approaches, that it's often hard to find test step implementations. So it's got search with the possibility of narrowing down through different filters where you can find existing test step implementations. And if you click on them, it just copies them to the clipboard, and then you can just dump them in. And you can even save. So if you've got people who don't want to use a developer IDE, they could actually use this. But obviously, it needs to be under source control. But yeah, you know that. You're all developers. But I think the most valuable thing about it actually is it is a tool that allows test automators, testers, and developers to literally stay on the same page. A lot of sort of our functional experts, they don't understand Python code, but they understand this. And to get your tests right, you kind of have to meet in the middle and somehow make sure that the step you're using is doing the right thing so that your test is testing what it's supposed to do. So for example, I have depth boundary is X meters. This is a nice Gherkin feature. It's called scenario outline, and it actually loops through with all these inputs. And then if I click down here and I will search for depth, I typed depth. Did I type depth? It's hard to see. Yeah, one thing. Okay. Yeah, so here's the implementation. So yeah, you could say I'm using this assert for checking the depth boundary. Is that right? So the tester says to the developer, and the developer goes, yeah, NF camera control settings, grep subject boundary. Yeah, that'll get the right thing out of the log. And so that way you can ensure that you're actually writing tests that test what they are supposed to test, which is kind of a basic requirement. Merge requests, or no, pull requests in GitHub are welcome. I have also, I guess it was here, put recently updated instructions about how you can integrate the tool with your own repo. So if you have Python behave tests, basically there's a quick little snippet that shows you how you can actually use this. So you can have what I like to call test review, a la code review, where you sit down and is this test doing what it's supposed to be doing for the team? Really nice if you're working in cross-functional teams with sort of embedded auto testers. Just to go through what the test is actually testing. It's testing what's called subject area, and subject area is a what is used for what's called neat symmetry. Neat symmetry basically in a meeting gives everybody their little box. So if you're connecting from home, you're used to getting your little box, and what usually happens is the 4 people sitting in the meeting room have their little party in the meeting room, and you're off in your little box, right? And you feel very, very alone and not included. Neat symmetry goes ahead and cuts up the picture using face recognition, artificial intelligence, and gives everybody their box. So Camilla and Han Solo, you see the box they're not going to get because that subject boundary setting at this point when the test is running is set such at they're too far back. But the next we adjust, and suddenly Camilla is in the meeting, right? And so that's what we're testing. We've just increased the depth setting to maybe 2 meters, but Han Solo is still Solo, right? And it actually also makes it so that if you're damned to a shared office space, you don't get other people interlopers. Han Solo doesn't come creeping into your meeting. So it's kind of almost the thing that distinguishes Neat as a video conferencing solution from our competitors. So yeah. So summing it up. I'm sure all of you hang out at lolgif.ru all day right now, but summing it up, the main focus should not, I will argue, this might be a controversial point, on last night's test results. The focus should be on trends, or maybe I should say the main focus should be on trends over time. That is to say, the focus should be on climate rather than weather. You cannot escalate every test failure. You don't want to escalate every test failure. It's not a way to sort of make good friends. It's wolf, 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 and then the actual wolf comes and you're kind of screwed. So hit the punish button when you see a bad trend. I was going to do something about that, but we'll just stop there. More situational awareness. Questions? Yeah.
Could you say something about how this relates to like unit testing and kind of the responsibilities, I guess, between you as the test person and the developers?
I did a talk about that last year at TechTown. So you can, if you search for it, there's a talk about it. That was at a different company, but we were writing tests, unit tests using Catch2. Are you familiar with Catch2? Yeah, so it actually allows you, for example, to define tests in kind of Gherkin given when then style language. And so basically we were there working in cross-functional teams where the testers were working alongside the developers and sort of involved in all conversations, and so could definitely give input into how the unit tests written in Catch2 were written, and they were written. They had a lot of C++, but they had the sort of the core of them was this Gherkin language, which is understandable for somebody who knows the domain. So basically, my experience there was that the tester would take into account what is covered by the end-to-end tests. There is sort of the normal division of labor, which says things that are really close to code and technical, that's the developer's responsibility, and sort of the fluffy requirements, end-to-end stuff is the test automation, functional test automation person's job. And that's true, but I think, for example, the tests, some of the tests I was looking at that point in my career was recognition and testing really, really big recognition algorithms, right? So it was definitely putting together a whole bunch of software components, but given that it was easy to mock all the inputs and cover all kinds of wildly complicated scenarios that would be incredibly difficult to cover with a functional test on real hardware, right? I, as a tester, could read those tests and understand that, yeah, that case is covered. I don't have to struggle to cover this corner case on a real machine, right? So end-to-end tests, I'm basically focused on end-to-end tests on real hardware with embedded software. But I mean, I think it's great if you have a holistic view of testing and basically make sure that you're covering all the important requirements where it makes most sense, right? You can write unit tests through the GUI running on real hardware, but that's not a good idea, right? So write tests where it makes sense, and then just have a holistic view of where things are actually covered. Does that answer your question?
Yeah.
Yeah. Any other questions? Okay. Thank you very much. I'm available for questions if you think of anything afterwards.